We're here to discuss fasteners. A fastener, by definition, is literally something that fastens to something else. That can be simple as tape, Velcro, staple. In the industrial world, a fastener can be anything from a screw, to a rivet, to an anchor, to a bolt, or specifically, a hex head cap screw. This would be a hex head bolt. There are socket head bolts, also known as a trade name by an Allen bolt. Today, we're going to specifically talk about hex head bolts. Now, a hex head bolt gets its name because it has 6 sides, as in a hex, and you generally use either a socket on it or a wrench to tighten it. A head of a bolt can tell you everything that you need to know about the bolt. It tells you the country of origin, it tells you the strength of the bolt, it tells you the grade of the bolt. Also, by looking at the bolt, you can just see its plating. This happens to be a zinc yellow, a dichromate plating. There is also a straight zinc plating, and then there is also a plain finish or a black unplated bolt. Now, bolts can be broken down into 3 main strengths. You have grade 8 bolting, you have grade 5 bolting, you have grade 2 bolting. The easiest thing to remember in identifying a bolt is when you look at the head of the bolt will have lines on the head. The easy formula for determining the grade is you take the number of the lines on the head and add 2. So, for instance, a grade 5 bolt has 3 lines, 3 plus 2, 5. So when you look at the head of the bolt, a grade 5 bolt would have 2 lines, a grade 8 bolt would have 6 lines. Some bolts have no lines on the head. That would be a grade 2 bolt. Grade 2 bolts are generally your very low, basic, run-of-the-mill, Home Depot style bolting, something that you're generally not going to find out in the industrial sector. Good for hanging signs, really just about it. Grade 5s, grade 8 bolts, those are the standards. So let's focus on a grade 5 bolt to start. A grade 5 bolt, as we mentioned, has 3 lines on the head. A grade 5 bolt has about 120,000 psi in its tensile strength. Now, what tensile strength is that is the limit at which the bolt will snap. Now, you have tensile strength, which means that the bolt will snap this way. And that means it takes 150,000 pounds per square inch on this bolt to stretch it before it snaps. You also have shear strength of a bolt. That's a completely different number, but also very valuable. And the shear strength is where the bolt snaps sideways across it. So tensile is vertical, and the shear is horizontal. Grade 5 is an excellent standard bolt that you'll find in shops all the time. It generally is enough strength to do the job. Grade 8 is definitely considered the higher strength bolting. I don't want to spend too much time today discussing a grade 2 bolt and its strengths because it is so weak and it's not something we try to market too often. But just to know that a grade 2 bolt, maybe roughly about 80,000 or so PSI. A grade 5 bolt is rated 120,000 pounds per square inch average tensile strength. Big difference between a grade 2 to a grade 5. Then you jump up to 150,000 pounds per square inch on a tensile strength of a grade 8 bolt. Big jump from 150,000 down to 120,000. Both have their needs, and depending on what type of application, that will determine which strength of the bolt that you need. Always better to err on the side of caution, going with the stronger grade 8 bolt. Again, as we mentioned, grade 8 bolt has 6 lines on the head, grade 5 has 3 lines. Take the number of the lines on the head plus 2. A lot of times a customer will say, I need a really strong bolt. I need a stainless steel bolt. Stainless steel bolting is a bit of a misnomer with that. It is actually very weak. It has a lower carbon content than the grade 5 and the grade 8 bolts. An average tensile strength of a stainless steel bolt in the 304, 316 series is just at about 100,000 psi. Much lower than 120,000 and the 150,000. Stainless steel bolting definitely has its applications. If you're near the coast, marine applications, something that you need non-corrosive. bolting for. That's where you want to go your stainless steel. Grade 5, grade 8 bolting generally has plating on top of it. The grade 8 bolting is readily identified normally by its zinc yellow color, grade 5 by its clear zinc plating. Bolting also has hot dip galvanized plating, which is where they spray the galvanized coating on top of the bolt, and that is excellent on outdoor applications. So in discussing a grade 8 bolt, which we'll take a look at right now, the grade 8 bolting, you see it has the 6 lines on the head. It also has a little symbol on the head of the bolt. In this case, it's a lowercase n, which is Nucor. That's a domestic made bolt. There's also an LE, which would be for Lake Erie. If you see a symbol that doesn't look like that, chances are it's an import Chinese made fastener. But for this case, we have a domestic made bolting from Nucor Manufacturing, and in identifying this bolt, we want to measure it. To measure the bolt, it's pretty simple. We have a handy little measuring tool here. What you can see is it has metric sizes on this side, fractional sizes on this side. So the first step, we saw the 6 lines on the head. We're ready to identify it as a grade 8 bolt, so we know that it's a fractional series bolt. Drop that right into the hole. You can see, 1/2 inch. Take the length from underneath the head of the bolt, 2 1/4 inches long. Flip it over to the thread pitch gauge on the other side. Fine until you can see where it matches. And you can see right there, it's locked in on that thread pitch. You can read the number, 13, underneath the head of it. Then you know the size. 8.8 marking on the head, automatically identified as a metric bolt. Slide it into the handy gauge. Find the hole that is the right size. Metric is up at the top. 8 millimeter. Find the length. Underneath the head, 50 millimeter. Flip it over to get to the thread pitch gauge, and you're spot on. Right on the 1.25. See, it's locked in. Now, there are also different thread pitches. There is the USS series, which is also known as National Coarse, and SAE series, which is known as National Fine. You may see it written as UNC, UNC for National Coarse, UNF for National Fine, and USS versus SAE. The difference between the two is the thread pitch. Now, the pitch of the threads is in the fractional or English diameters. That is the number of threads per inch. That's what TPI stands for. So you may see that TPI, that stands for threads per inch. So this is a 1/2 inch bolt. This has 13 threads per inch for a national course. 20 would be for the fine. So for instance, that means that in 1 inch of this bolt, there are 13 individual threads. This would be a coarse threaded bolt. On the fine thread bolt in a 1/2 inch, you could count 20 threads per inch. Now, switching gears between fractional and metric sizes. Metric sizes have an equivalent between grade 5 and grade 8 as well. A grade 5 metric bolt is designated as class 8.8. 8.8 and grade 5, these two are very comparable. They are both at about 120,000 psi tensile strength. The grade 8 bolt has its counterpart in a class 10.9, and they are readily identified on the head of the bolt. Anytime you pick up a bolt, you can look at the numbers and the markings. Metric bolting does not have lines on the head to identify it like the fractional sizes do, but you will notice it by the 8.8 or the 10.9. Thread pitches on metric bolting goes by the gap in between the threads. So, for instance, a 16 millimeter bolt in its core series is 2.0. Now, what that means is that there are 2 millimeters between each individual thread of the bolt. Remember, fractional sizes count the number of threads per inch. Metric series, they count the gap in between each thread. They do have a coarse thread and a fine thread series. The most common is going to be coarse. Another thing that we can discuss about readily identifying a fastener is its magnetic properties. With a handy little magnet, you can see that it's going to attach to the bolt because of its carbon content. A stainless steel bolt, for instance, has very low carbon in it. It's not magnetic. So if you're handed a bolt, you're not sure if it's domestic or import, or if it's stainless or a carbon steel bolt, easy thing to do, you can take a magnet to it, and if it sticks, it's going to be, generally, it will be an alloy steel bolt. If it's stainless steel, it's not going to stick. That's a good selling point, easily be able to identify fastener that way. The other thing, as we mentioned, the physical appearance of the bolt, the color. If it's zinc yellow, generally being a grade 8 bolt. Clear zinc, it's going to be a grade 5 bolt. Now, I currently stage these bolts in position in terms of its strength from weakest to strongest. The first bolt is the stainless bolt, which you can see marked, which has a 304 on it. That's 304 stainless steel, also similar known as 18-8 stainless steel. The next bolt to the right of that, you can see has no markings in terms of lines on the head. Again, number of markings +2. This is a grade 2 bolt. No lines, grade 2 bolt. The next bolt to the right of that, you see has an 8.8, and then the manufacturer, which would be SM, listed on the top of that. 8.8, similar to a grade 5 bolt, again about 120,000 psi. Remember, 8.8 will automatically tell you that it's a metric bolt. Next bolt to the right of that is a grade 5 bolt, identified by the 3 lines on the head. Already will tell you that that is a fractional bolt. It's going to be about the same strength as that 8.8 metric bolt. Finally, we come to the grade 8 bolt, identified by the 6 radial lines on the head. 6 lines +2, grade 8 bolt, one of the strongest bolts on the market, 150,000 psi tensile strength. Oftentimes, there will be a need for a bolt that's even stronger than a grade 8. A bolt like that does exist on the market. It is generally known as either an L9 bolt, which is the manufacturer. There's also the F911 series. Both are rated at about 180,000 psi, significantly higher than a grade 8, 150,000 tensile strength bolt. L9, 180,000 pounds per square inch. It has its metric equivalent of a 12.9 grade. So it would be identified easily on its head as a 12.9. You can see that listed right here on the head of the bolt. 12.9 is the equivalent of an L9 high-strength fastening system. The threads per inch. There is a coarse thread series and a fine thread series in both inch and metric bolting. The threads per inch are identified after the diameter of the bolt. Let's take the 1/4 inch, for instance. Small bolt, 1/4 inch diameter, -20. What that 20 means, it is 20 threads per inch. The fine series on the 1/4 inch is 28 threads per inch. So that means that between the coarse and the fine, there are 8 different threads per square inch. On the metric series, there is also a coarse and a fine. 6 millimeter, the M6, is a -1, 1.0. Again, that's the thread pitch. And that, in metric series, is the distance between the 2 threads. 1 millimeter separates the threads on a coarse thread in metric. 0.75 millimeters is the distance between threads on the fine series of the metric. Coarse, fine for inch and for metric. So by looking at the head of the bolt, you're able to determine the strength of the bolt, the grade of the bolt, the country of origin of the bolt. By looking at the plating, you can determine whether it's zinc yellow, dichromate, a clear zinc, or a plain unfinished coated bolt. When you arm yourself with all of this information, you'll readily be able to identify any fastener that's out there on the market.